I think I have like more fun.
Oh, let's see. I want to try. Let's see.
Plus, I just went through high school. Oh, I'm so sorry. Dude, I didn't think it was like so amazing.
Okay.
A little bit of a slow thing. It's because that's again why like.
Sorry, guys.
I got 1 equals that.
4x plus 5.
This
is very.
Oh.
Yeah.
You just because there's an X.
So that you subtract
4x.
and then you divide by 1.
Not quite.
Yeah. Yeah, that's like basic, but it's like.
Alright, I'll stop. Someone, I'm supposed to be able to turn just this off. But it is not.
Yeah. I saw the video. Yeah.
Okay. Yeah.
For some reason, he decided to take smart kid classes. I was like, that help you?
Alright, guys.
A little bit, like, assume the pain.
Let's take a look at this thing. What was the hardest problem on here?
Crap. 3B.
So 1C,
All equally hard.
all equally hard. All right. It's not true. All right. I'll accept that.
It's my truth.
This guy, 3B.
Yeah. I saw the video and gave up.
All right. All right. So let's see. Number 1A. I talked to a few groups about 1A. This is always true. Kind of like the grammar of math is order operations. And one of the hardest things to learn about a different language, the vocabulary is just memorization. Grammar is like a whole different thing. So if you ever learned a different language, you know exactly what I mean. Especially if English is your second language, I apologize. English is like, let's make this as hard as we can for everybody. So order operations, what's the order operations? PEMDAS. So it's parentheses, exponents, blah, blah, blah. So it's please excuse my dumbass son. Or dear Aunt Sally. It's really unfortunate. Let me kind of blow you guys' minds. There is no division. There isn't. Division does not freaking exist. There's only multiplying by the reciprocal. So when I divide something by 2, isn't that multiplying it by a half? The reason I want you to understand that doesn't mean you have to stop talking about division. We call it division, but we also understand it's not its own thing. It's just multiplication. So that's why multiplication and division, you do it as it comes because they're equally important. Neither one is more important than the other one. But they are both more important than addition and subtraction. That's at the very end. That's at the ass end of PEMDAS, right? So in this problem, I have had teachers that have taught that multiplication comes before division. And that is so wrong. It could have been this, easily. But this one, when you try to say it, you sound drunk, so it could get you in trouble, right? Step out of the car. So the right way to look at this is like this. Definitely parentheses, definitely exponents. Either one of these as they come because they actually are the same. And there is no subtraction, there's just adding the opposite, right? So that's why they are on the same level. So what is the very last thing we're going to do in this problem? What's at the ass end?
Add and subtract.
Yeah, so this 3 plus is just going to come for the ride. It's 3 plus we don't know yet. So it's just going to come for the ride, right? What is the very first thing? Parentheses. So what is in the parentheses? 2. Yeah, 3 plus 2 squared divided by 2 times 3. What's next? By the way, real quick, fight the urge to say 6. Because where is that 2? Wouldn't it be on the bottom? Right? Isn't this divide? What's the only number that I'm dividing by in this whole thing? The way it's given to me. What's the only number I'm dividing by? 2. So it is not fair to suddenly go, no, I'm going to divide that shit by 6. So imagine somebody like, you're going to divvy up money, and there's 2 of you, and they're like, I'm going to divide by 6 and give you. Like, screw that shit. You're going to cut it in half. So it's not fair to cut it by 6ths when the only number dividing is 2. You can't make that 6. You guys follow what I'm saying? So you don't have to write this, but this is the reality. The reality is this. Yes? The only number on the bottom is 2. How the hell does that become 6, right? You guys kind of with me? So multiplication does not always come before division. It just as it comes. Multiplication is not a higher order importance than division. They're the same. Okay? So you don't have to write it like that. So what's 2 squared? Crazy shit. What is, then I do, so this is last. What's 4 divided by 2? 2. 3 times, 2 times 3? 6. Holy shit, and then no. Okay. Everybody with me? So, I only go on Facebook to kind of keep up with some people's stuff, right? When I go on there, there's invariably a stupid post and people arguing, it's 1, it's 15, a little tear comes out. It's just order operations. It's so sad that so many people don't know how it works. But it's not arbitrary. It is that. It is just the reality. There can be no 6. The 2 is the only thing on the bottom. Are you guys? I'll stop. I'll stop. You can tell it's a little bit like, okay. How did part B go? One thing to notice about part B, is it an expression or an equation? Equation. How do I know it's not an equation? No. Because it doesn't have equal sign. So this is just purely a like terms problem. You guys see that? What's the very first thing you have to do though? Because some stuff is stuck. What stuff is stuck? The x minus 5y is stuck. It's not free to move, right? So the very first thing, of course, we do is distribute. Now, what are you distributing though? Negative 2. Okay, guys. So what's so let's write all this shit. 5x minus 3y plus 10y minus 2x, and then what's this?
Positive 10y.
Plus 10y. Oops, I forgot my y. And now you just put your like terms together, right? We got 5x's, I lost 2, so now I got 3 x's. I got 10 y's, another 10 y's, and then I lose 3. 17. You guys with me? And again, you know, if it's been a while since you took math, if you just were never really good with it, whatever, this stuff will leak out your brain really quick. How often do you do that day to day? Not, right? But it's still important. It's still another way of putting together things, and it's a step in the direction of being able to do higher level stuff, which leads to better jobs and all this kind of stuff. I talked to one group about part C. So let me ask you this. If it was instead this problem, why does this problem rock except for how bad I write? By the way, that's how bad I write, okay? So,
Subtract it.
sorry. Yeah.
Because I think it's called the denominator, the bottom number is the same.
Yeah. So watch this. What's 11x minus 7x? 11x minus 7x? 4x. What's 11x minus 7y? 11x minus 7y, I don't know. Do you see how that's like terms? How many 12ths do I have? 11 12ths. And I'm taking away 7 of those 12ths. So of course, what do I have left? 4 12ths. Like freaking terms, yes? The bottoms being the same is exactly the same as needing like terms, right? That's why this problem is awesome, and that's why I didn't give you this problem, because I mean, so I would reduce that, right, to 1/3 is equal. Okay, that's not the problem we had, damn it. We had this one. So this is all about the opposite of reducing. This is building it up to the point where the bottom's the same. So really the question becomes, what number do both 12 and 8 multiply up to be? 24. Kick ass. I love it. By the way, let me show you. You don't need this. These numbers are small. Not hard to figure this out. But let me just show you something. What's the biggest number they have in common?
Four, would it be? Do you want 4?
4.
Oh, you're talking about.
You with me? You with me? So are you with me? 12 is 4 times 3. 8 is 4 times 2, right? Are you with?
Yeah.
Okay. What is he missing that he's got?
3.
Now he's already got a 3. What is he missing that he's got? A 2.
Okay.
So you double the top, you get 24, right? What is he missing that he's got?
3.
3. So if you triple, you get 24. So when the bottoms get bigger and harder to think about, you can actually just break them down and see who's missing what and give it to them. It's kind of like if you have kids and you give 2 kids ice cream and one got sprinkles and the other one didn't, what's going to happen? So, okay, you're missing this, and then this first one got something else. So you give a little bit there. Me, it's probably better I don't have kids because I just eat all their ice cream. Like, nobody gets ice cream. So I like to think of this as give them what they're missing relative to the other one. Make your kids happy by letting them get the same. He got more ice cream, okay. He got more sprinkles, okay. Sorry. So 24, so if I double this guy top and bottom to make it legal, and then of course this guy, what do I do top and bottom? Times 3, so then I'll get, I can't even see, 21 24ths. So then how many 24ths do I have left over? 1. Kick ass. Okay, I like it. I like it. I like it a lot. Alright, and then we got one of the worst things in math is the top of the list always when I ask people what do they not like about math. What is it? Huh? Word problems?
Words.
Yeah, words. It's not math's fault. But word problems suck. Why does it suck? Because math is a different language. It is translating from English to Mathish. This is not that terrible, but I wanted to give you 2A. Because if anybody did 5 minus 3, you're wrong. That says 5 less than 3. So what would that look like mathematically? 3 minus 5. Not math's fault. That's English's fault. English is weird as shit. Right? So the way we say it in English is the reverse of the way that we actually calculate it, right? So 5 less than 3 would be 3 minus 5, and what's 3 minus 5? 11. So the way I think about this, again, some people have trouble in sign numbers. If I have $3 and I owe you 5, if I have $3 and I owe you 5, if I give you all my money, I still owe you 2. 11. So what about this one? You had to remember what the hell that meant. What does product mean? Multiplication, 11. So it's 2 more than the product of 9 and 8. So what's the product of 9 and 8? How do you write that?
9 times 8.
And then 2 more than that. Plus 2. Yeah. And of course 9 times 8 is 72, plus 2 is
34.
9 times 8 is 72, right? What's 7 plus 2?
9.
You guys, anybody know what I'm talking about? Hold on to it. What's 9 times 6?
54.
What's 5 plus 4? 9. What's 9 times 12? 108. What's 1 plus 0 plus 8? Oh, what? Anybody know that? If I give you a number, I do not care how big that number is. If all the digits add up to be a multiple of 9, the whole number is divisible by 9. Has anybody ever heard that before? I know you have. You have. If you believe you've never heard it before, are you a little angry? That's a good thing to know. Do you agree with me? I know calculators exist, but we humans made numbers up. We should know some shit about it. So part of what we're going to learn this semester is all like for most of the numbers, do they have divisibility rules? So for 9, if I give you any number in the universe, you add up all the digits. If the answer is 18 or some multiple of 9, the whole number is divisible by 9. Isn't that kind of cool? Cool might be too strong a word, but you know, it's in that direction. Okay. Okay, fast and Indy? That's even better. Okay. Now we've got equations, right? We're actually not going to talk about algebra until basically the very end of the course. But you all should come in with some algebra under your belt. So I just wanted to see where we were with this. I know 3B freaks us out. Fractions in general, I understand. Right? Because you don't have to work with fractions very often in real life, right? It just doesn't show up a lot. Maybe with some tools, right? So any of you guys use tools, you have the 9/16 and whatever, blah, 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 right? Depending on if it's metric or if it's whatever. Okay. But just like we did up here, because all an equation could be sometimes is the first problem could be like terms. What's the very first thing I should do in this?
Distribute.
Yeah, distribute. Get that right up in your face there. So then you distribute the 3, what do you get?
Blurriness.
You get what?
Oh, it wasn't focused.
Oh, I'm sorry. It does take it a moment. Sorry. You get,
3x.
3x.
okay, cool. All right. And then what's the next thing you can do? Yeah, so you get 4x minus 2 equals 5x minus 3, right? And now you're basically 2 steps away, sort of. So the whole point of algebra with solving basic equations is get all your x's on one side, all the numbers on the other side, right? I kind of like to try to keep my x's positive so I don't have negatives come in. So I'm going to subtract 4x. And I could at the same time add 3. So then I get 1 equals x. Real quick, what does that mean? I know you can't see it, but too bad. What does that mean? Yeah.
Although you can rewrite all the x's and put 1 and it will work.
Yes! Good. So when x is 1, that is a true statement. That's what that means. Does every equation have an answer? Nope. You could actually work this problem out and get 1 equals 0. And that is math saying, hey, your equation's bogus. I don't have a mouth, so the only way I can communicate with you is give you weird shit. And you go, when is 1 equal to 0? Never. So when's that equation work? Never, right? This one came out nice. We got an actual number for x. So like you said, if I put a 1 in for x, it would work. This one, the beautiful thing about an equation is, most of the time, if you look at an equation, you're like, I don't like that part. Kill it. My algebra is very violent. There's a lot of death and killing. So I'm really sorry. What part of that problem do you hate the most? The 5. Because the 5 is why there's a fraction. How do you kill the 5? What's the 5 doing? So if I multiply everything by 5, fraction's dead. Right? Ding dong. The fraction's dead. So if I multiply both sides by 5, which means it would distribute, 5 times this, the 5s are dead. So then I just get 10x minus 3. Is that cool? What do I get here? Is that alright? You guys cool?
Yeah.
So what do I get here? 10x. And over here? 20x. So I kind of wanted to get you ready. So if you put the like terms together, what do you get? 20x minus 3 equals 20x. Now get your x's together. What do you have to do? And the really funny thing is, a lot of students hate letters in equations. And what's funny is you guys desperately try to save it, even though you hate it. The x's are dead, right? 20x minus 20x, 20x minus, that's 0. There's no x's left. So on this side, what do I have? Negative 3. What do I have on this side? 0. Now, understanding, when you solve an equation, the correct way to interpret this is, when this is true, then the equation is true. Same thing here. When this is true, the equation is true. Is the equation ever true? Because negative 3 never equals 0, correct? So what's the solution? No solution. little faster over that, but is that, any questions on all that stuff? And again, if there were major issues with some of these things, as we hit them, we will review them. I just kind of wanted to throw this at you, just see where you were. Stay with me now. We're going to do like a little bit out of chapter 2. I'm going to head out. I don't know, in case you guys can see, I woke up this morning with my eye feeling a little weird. It's getting a little swollen. It's getting a little funky. So I'm like, okay. So I'm going to head out to the urgent care. But we'll do a little bit of section 2-1. The reason, I don't know if you guys noticed, in the homework, I skipped chapter 1 at first.
Yeah.
Here's the reason why. The first time I taught this course, I did chapter 1 first. Chapter 1 is word problems, which we discussed earlier is normally everybody's kind of like, ugh. So I decided to start with chapter 2, get everybody kind of grounded. Even when we do chapter 1, the most important thing when you're doing it is, show me you know what to try. Getting the answer is icing. Showing me you know what to try is the important part, right? I don't know if you guys, normally people don't quite understand what I'm saying. If you don't get the answer, that's not the end of the world. The whole point is, do you understand all of the different approaches we discussed and how to implement them? That's what's important. Okay. So we will start with chapter 2. Turn you around. I'm not sure what is happening. I think it's feng shui class up there, maybe? I don't know. Interior design? Sounds like thunder. All right. What's that?
Sofa moving 101.
Oh, sofa moving, yeah. Pivot. All right. All right, this is exceptionally weird. Highly localized thunderstorm. Huh?
I feel like you almost need to go check, like see what it is.
I kind of want to, but you're more important. Yeah, I need a broom in here. Every room should come with a broom. What's really weird is that's the roof. What the hell's going on? Are they? Oh yeah, we never did finish the roof. Oops.
I thought the roof is.
It is? Okay. I see. So they probably made a big circle, and now they're putting it back. All right. When I say the word set, mathematically, what comes to mind? Because some of you guys, it might be tennis. Talk about a tennis set. Yeah.
Usually
Say again? Oh, okay. I think you're thinking about a point. Okay. So a point is kind of interesting. It's sort of a set, but not really. A point is kind of like a certain object by itself. It's got two parts, but it's not really. You could have a set of points, but one point by itself is sort of like a geometrical object. It's not really a set of stuff. Yeah.
It's like a list.
Yeah, okay. It's like a list. Kick ass.
I was going to say exactly the same.
I'm sorry. Okay. Stole his thunder. So for example, here's a set. Ground shaking set. And normally we give sets capital letter names. So that would be the set A, right? To make a kind of more interesting set, how would you represent the set of all natural numbers? And the first thing you have to wonder about is, what the hell is a natural number?
You can do 0, 0,
Careful,
1.
careful.
Oh, yeah.
Those are whole numbers. Yeah, so real quick, natural numbers are what came naturally to us. So when I'm teaching like pre-algebra or something, I'll tell students natural numbers are what came naturally to us. We're cavemen, we're like 1, 2, 3. We're not saying 1, 2, 3. So we developed those words later, but you're with me. 1 thing, 2 things, 3 things, right? Later this semester, we're actually going to learn Babylonian number system, Egyptian hieroglyphic system, Mayan numeral system, right? I don't know how you feel about that. It looks like most of you don't like this idea. Beautiful. For example, the Mayans have what I call pancakes and blueberries as numerals. We'll talk about that later today. So, when I have natural numbers, they're what came naturally to us. 1, 2, 3, right? Whole numbers Entire civilizations did not have the idea of zero. It had to be invented. And then, for example, the Babylonians, they understood zero, but they didn't have a symbol for it. So when they were trying to write the number 402, they just wrote 42 and hoped people understood there was a zero, right? They didn't have a symbol for it. They developed a symbol, and then their civilization fell. So somebody's like, I made it. Oh, shit. We had a good run, everybody. So if I wanted to represent the set of natural numbers, and if you wanted to list them all, how long would it take you? Correct. And then your kids would take over, and their kids would take over. So what's the quick way to represent all natural numbers? 1, 2, 3, dot, exactly.
Ellipses.
What is it that I've set up, though? Before I can put the ellipses, I couldn't just put 1 comma ellipses. Because what have I not set up for somebody? A pattern. Kick-ass. So if I wanted to do the set of all even whole numbers, right? Even integers, there's B. Even natural numbers. 2, 4, 6, dot. So you have to give enough to establish a pattern, right?
Is
Part of
3 the go-to number? I'm sorry. Is 3 the number that you
3 normally is good enough. What's really funny is there are situations where I can give you 3 numbers and there could be multiple answers for the next number. And they're all valid. Because there's multiple possibilities for what they point towards. And if I was teaching a stats class, that would have been an example of you haven't got a big enough sample because you don't know where it's pointing because you didn't take enough data points, right? But we're not in stats class, so for you. Okay. So everybody with me, this isn't too ground checking. You've all seen, if I really made that symbol nice, it would look like this, right? It would look like tactic notation. Okay. So, if I ask you, is 11 an element of the set C? No. The symbol for an element of is this. It kind of looks like a little E, which is nice. So if I wanted to say 11 is not an element of C, that's how I do it. Not surprised, a little cross through it, sort of like don't walk on the grass. You with me? Okay. And again, this could be something you guys all know, but normally that symbol is not immediately well known. What would the set of integers be? Anybody remember what integers talks about? Yeah.
Aren't those numbers? Just any numbers?
No?
Doesn't it include like fractions and decimals?
Not quite. That would be rational numbers.
Is it all real numbers?
Nope. That would be real numbers. So the thing about banks, what happens is some people, what numbers do banks unfortunately know really well? Negatives. So I like to tell a little story about this caveman. He's got 3 rocks. 1, 2, 3. Ugh. And then he loses all of them. Now he's got to invent the idea of 0. That's whole numbers. Then he has to borrow a rock because you need a freaking rock. So now he's in debt. He's got -1. He's in debt. Do you understand what I'm saying? So he has to invent the idea of negatives. So all integers are whole numbers plus the negative whole numbers. So how would I do that? So what's the smallest integer?
0.
No, this is a very strange question because it includes negative numbers, correct?
Infinity.
Negative infinity. And then what's the biggest integer? Positive infinity. So how the shit? So real quick, these ellipses, what do they really represent? Where does this list stop? How long is this list?
Never.
Infinite. So this is only a one-directional infinite set. Integers go to infinity in both directions. So how many ellipses will I need? 2 sets. Yeah, so dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Let me stop for a minute. You guys have seen kind of variations of this, I'm sure, somewhere. Maybe, if not, does it make sense so far? All right, some of you guys have a look on your face like, you lost me at hello. All right, so if you're ever at a point where I'm saying something that doesn't make sense, feel free to ask immediately. So I want to say this. Anytime you have a question, at least 8 other people have that same question. Trust me. So also, before I forget, part of my job as a teacher is to know when to stop questions and keep going, to keep us on pace. It's not your job to self-censor and go, I don't want to ask questions and slow us down, because that's my job. You ask a question, and if I have to keep going, I'll say, see me after class or whatever. You guys kind of with me? Okay. One thing I like to say is, if I'm going too fast, deal with it. No, if I'm going too fast, slow me down. And if I'm going too slow, deal with it. There it is, Jeff. Does it make sense?
Yes.
Okay. One more thing, and then I think I'll let us out a little early. Yeah. Don't get used to it. So what if I had one set look like this, and the other set looks like this? Is one of those sets contained in the other one?
Yeah.
So do you know what the word would be for that? If there is something that is part of a bigger set?
Subset?
Subset. Right. I was thinking about like sublet. Subletting your house. So subset, so I would say G, well actually if you got it, F is a subset of G.
Is that what this C means? This is subset?
Yeah, the little, looks like a C dude. What's funny is, let me just ask this. Anybody see what symbol that's, which set's bigger? Has more stuff in it? G. With that in mind, what does this symbol kind of look like? It's a softened version of an equality symbol, correct? So it's almost like you look at it like F is less than G. But we don't use that symbol because it's more than that. It's not just that F has less stuff. It's that F is actually contained in G. Does that make sense? You with me? But it is kind of related to inequality, so like a less than. What about if I have another set that is this? How do these two relate? Say again.
H would be less than F?
No.
C would be.
Does either one have anything the other one doesn't?
They just go in the other direction.
Yeah, I just put them out of order, right? So if I was like 1, 0, negative 4, come with me, and someone else is like no, negative 4, 0, 1. It's the same group, yes? So what symbol do you think I'd put in between there?
Equal.
Yeah, I could put the equal sign. Now watch this. I could also put this sign.
Less than or equal to?
Less than or equal. It's exactly the same thing as less than or equal to. Is 7 less than or equal to 7?
Yeah.
Hell yeah. Because it's equal to. It's less than or equal to. Now, of course, which one would you rather use? Which one just makes more sense?
Equal.
Freaking equals, right?
Yeah.
But this is also fine. Let me make sure that's really rounded. Yeah,
Can you flip the sign then and do the?
Totally.
equal to?
totally.
Greater than or.
Yeah,
Okay.
I like it. Because if it's equal to, it doesn't really matter which way it goes. I like it. Are you guys with me? So real quick, do you understand I could do this and it's still true? Because again, it's a subset of or is equal to. And that's true. Just need one of them to be true, right? I like it. All right. That was the smallest little dipping of a toe into section 2.1, right? So we'll call it a day. If you have any questions, come up and see me. Otherwise, I'll see you guys on Thursday. Thursday, we're going to take a little field trip real quick. Probably at the end of class. Last thing we'll do.
When we do these papers, just toss them.
If you want to, sure.
Okay.
Up to you.